This is your last lesson. I know there are tears right now. Wish I had my babies right here so I could teach you all this in person. Maybe make some brownies for you or something. But just know in my heart, I'm making brownies for you. Integrals of inverse trig functions. There are 3 of them. Why are there only 3? Because the cofunctions are just negative and we can deal with a, constant. That's not a big deal. So we are going to write these down. Remember, your whole purpose in integrating is if it can look like this, you may write it like this. This is the formula. Once you make it look like this, you've got to make it look like the left side. Then you can write it like the right side. Okay? So write those down, pause this for a moment, and then if you've got your little derivative sticky note, you can have that on the side because we might throw one of those in there. All right, so our first question is going to be, when you look at these problems, I want you to notice first if they have a radical or they don't have a radical, because that's going to tell us which one of the 3 to use, really. So here I obviously have a radical, this one no radical. So this one I'm sure is going to be the arctan because there's no radicals in that one. Whereas this one is either going to be the arcsine or the arcsecant. And then if I look closely between arcsine and arcsecant has that extra variable outside, whereas the arcsine doesn't. So I'm pretty sure this is going to be good old arcsine. So here's what you need. You need know where your a squared is and where your u squared is, and then we actually need to take the square root of them to have a u and an a in our final output. So our a squared, again, a squared minus the u squared. Our a squared would be 1, which means your a is 1. Your u squared would be 4x squared, which means u would just be what's being squared? 2x, right? Okay, now we still need to check that the du, the derivative of u, is inside of here. So if I take the du, I would get 2 dx. We don't have a 2, so we need to divide out and get 1/2 du equals dx. Okay, so now let's rewrite this with everything that we have. So this dx is going to be 1/2. I'm actually going to pull it outside the integral. I'm going to replace this with the du then. Then underneath here, I would have the square root of my a squared minus my u squared, which we have our a and we have our u. And so now that it looks like this, I'm going to rewrite it like this up here, which would be 1/2 arcsine u over a plus c, or 1/2 arcsine 2x over 1 plus c, obviously just 2x, but just so you see, very simple, easy. We're making it look like one of those 3 choices above. Okay. Let's do this second one here. So this is obviously no square root right here. So I know it's going to be the arctan function. Okay. And again, looking at my formula, I need an a squared and a u squared. So my a squared would be the 1, meaning a would be 1. My u squared would be the 9x squared, which would mean that u is 3x. Still need to account for the du, so this would be 3 dx. I don't have a 3, but I have a 12. So what does that mean? Well, that means 12 is actually 4 of the 3, so 4 du is equal to 12 dx. So this right here is equivalent to 4 DUs. So when I go to rewrite this, I would have the 4 pulled out, du, over my a squared, my u squared. And once it looks like that, once it looks like this, the 4 is pulled out, I would write it as 1 over a arctan u over a plus c. So now I look back at all that I wrote over here. So 1 over 1, which is 1. What? I forgot to account the 4, so multiply by the 4. Let me bring that in front. Arctan, my u is 3x, my a is 1 plus c, or 4 arctan 3x plus c. Okay, moving on. See, they're not bad yet. Just kidding. All right, this one, a little different. So we have a no radical, so I know it's going to be the arctan again. So let's just find out what my a and my u are, but my a squared is 4. This is my u squared, x minus 3 squared. So then that means my a is 2, and my u would be x minus 3. We need to take a derivative. Derivative of x minus 3 is just 1 dx. And so let's see. That's not a big deal. There's nothing to deal with the 1x. So let's rewrite this then. This would be, again, if you look back over here, if it's arctan, it's 1 over a arctan u over a plus c. So 1 over a arctan u over a x minus 3 over a plus c. Pretty simple. Okay, this one is interesting, and it kind of goes against everything that I've shown you in the past, but I do want to show it to you. I believe you have the same homework problem tonight, so might as well just do it. There is a radical, so then looking at my 3 choices right here, it's going to be an arcsine or an arcsecant. But since there's an x outside, I'm more than likely sure it's going to be an arcsecant. So let's kind of establish what our a's and u's are, and then we'll follow that pattern. So this would be my u squared, which is x to the 4, which means my u is x squared, which means my du is 2x dx. Well, we have a problem here because this is in the numerator, this is in a denominator, this is 1 over x. So we are allowed to divide out the 2x this time. And this would be 1 over 2, watch how I'm writing this, times 1 over x du, which equals dx. So what that means is, I could have written it as 1 over 2x, but I just want to show you this. So this right here, that guy right there, if you cross him out, according to what I have down here, is equivalent to 1 over 2 times 1 over x du. So this is 1 over, I should just probably keep it as 2x. And then I have 1 over x. And then my x to the 4th is u squared My a squared is 4, which means that a is 2. We didn't write that over here. So this is minus a squared du. Okay, 1 over 2x du. What does that do? I know this seems so tricky. Well, if you notice what happens, 1 times 1 is 1. 2x times x is 2x squared times u squared minus a squared du. And that x squared is u. So I can now rewrite this as 1 over 2u times u squared minus a squared du. Okay, and then what can I do with that 1/2? I can just pull it out in front. 1/2 1 over u times u squared minus a squared du. So I know this one's very confusing. And it's something that you normally wouldn't do, divide by 2x. We never divide by x. We just say, oh, there's no integral here. But this case, it actually works out. So again, once you get it into this form, look at the form. Du is on top, but I pulled my du on the side. The u is on the side, the square root of u squared minus a squared and the 1/2. Then you can rewrite it and finish it off as 1/2, which is already there. So it equals 1 over a. So times 1 over a, which is 2, arc secant, absolute value of u over a, which is 2, plus c, or another way is 1/4 arc secant x squared over 2 plus c. Okay, I know that's tricky. If you didn't get it, honestly, don't worry so much. It's a calculus 2 thing if you're going to calculus 2, or my SPCCers, they need to know it, but no worries. All right, let's finish off. Almost done here. This has no radical, so this is a tangent problem. So let's find out what our a is and what our u is and keep going from there. So my tangent, again, is a squared plus u squared. So if a squared is 7, a would be square root 7. If u squared is this guy, cosine squared x, then u would be cosine x. Got to account for its derivative. The derivative of cosine is negative sine. Pull out that negative, so this would be negative du sine x dx. So this right here is the integral of negative du. And then this is my a squared, and that is my u squared. And so it looks really good to integrate, except that negative. I'm just going to pull it onto the outside when I integrate it. The integral of du a squared plus u squared. So again, what does that integral equal? It equals 1 over a with a negative in front. So negative 1 over a is square root 7 arctan u over a. So cosine x over square root 7 plus c. Okay, 2 more and we're done. This is a really valuable trick that I'm about to show you right here. So again, depending on if you're going to higher level math or not, this is really an interesting thing that you're allowed to do that I wish you all would remember. But you could try right now to do this as one, and it's not going to work. But you could always split this into 2 easier parts. Split your integrals. That's an important trick. So meaning I could write this as the integral of 4x over square root of 1 minus x squared plus the integral of 3 over square root of 1 minus x squared. I should say dx for both of them. And then you can take the integral of each one, and hopefully you can watch what happens here. So this right here, if I pull that 3 out in front, I'm going to do this one first, is 1 over the square root of 1 minus x squared dx. That one is, look, pull that to the side, and we pull that 3 out. Here's the square root of a squared minus u squared. So it's just arc sine u over a plus c with that 3 out in front. So this is just arc sine u, this would be u squared, so u would be x over, this would be a squared, which would be just 1. So arc sine x plus c. There's that one. This one, now this one's a little different because you have that 4x dx. You could actually call this your u. Okay. So my u is the entire thing on the bottom, 1 minus x squared. The derivative of that, the du, is negative 2x dx, which is really what? How is this related to that? It's negative 2 times it, right? Negative 2 du, which is equal to 4x dx. So that right there is negative 2 du. So I'm going to pull that negative 2 out in front. The derivative of, and this is the square root of u, or u to the 1/2, which is really negative 2 times the integral of u to the negative 1/2 du. And so this is just the chain rule. You just add 1 and divide. So if I add 1 and divide, I would get u to the 1/2 divided by 1/2 times the negative 2, which would be what? Negative 4 u, which is 1 minus x squared to the 1/2 plus 3 arc sine x plus c. So crazy one, isn't it? But completely doable. All right, last and final one. So this one, okay, for this last one, there's going to be a problem when you try to do that little separation trick. So you can try it, obviously, and see why it doesn't work. So you're actually going to want to do something called double substitution here. And I'll show you what that is. You've done like one problem like that, but again, not too many of these will happen on the homework tonight, but let's see. So if you look at this again, there's no radical, so it's definitely going to be arctan. So my a squared would be that this is, what are we going to let our a and b be? Normally your a comes first, right? So your a squared and your u squared. So when I had actually done this problem first time, I let this be my a squared, which I shouldn't have. Your a is usually just a single constant, or, you know, something like that. If we go to try to rewrite this, we will have a problem because we have an x minus 2, and obviously taking the derivative of this is just 1. So what we need to do is actually do a double substitution where x is actually equal to, minus that over, u minus 1. And you'll see why this is very helpful in a minute. But if x is equal to u minus 1 and then minus 2 over, and this is our u squared plus a is our 4, so that's a squared in that form. So then this would be u minus 3 over u squared. We'll just leave it as plus 4 because that's our constant du. And now I can actually separate this into integrals. So this would be the integral of u over u squared plus 4 minus 3. I'm going to pull that 3 out. Times the integral of, we'll put du. I keep forgetting my du. U squared plus 4. Okay, so this one right here is in the correct form now to write it as arctan. Okay, so this would be minus 3 times 1 over a arctan, and then your u, which is x plus 1, over your a, which is 2, and then plus c. Add that to the side. So that one was much easier to do because that was in the perfect form for arctan. And I'm just rewriting it actually right now. This one is going to take you back. This is why the beautiful thing of mathematics. This is actually the ln stuff. So if you let this whole bottom, I know this is hard to do, but this would be your u again, and the derivative of this would be 2u, which means you've counted for that part. You would actually have then divide out the 2, you'd get 1/2 the ln of that u squared plus 4, and then put plus c, which is 1/2 ln of, what's my u? X plus 1 squared plus 4. Okay, that was super hard. Most of your homework ain't gonna be like that. All right. Bye, y'all. Have a good one. Try some of your problems tonight. Email them to me. Last one. Bye.